to thank you all for attending this talk about how we deployed a virtual desktop infrastructure in our school. My name is José María and Alberto Bernat, it's here. We are two teachers at Flagship Secondary School in Barcelona. We have over 1,000 computers that we have to maintain. And we usually did a cloning system, but as we saw the virtual desktops systems, we tried some systems, and in the end we developed our own system that adapted exactly to the needs. What we will be explaining in this talk, first of all, is what is this software, IsardVDI, and key concepts of which things we improve with this software at different levels, and also how we solve all the problems that we had during these past years while using these virtual desktops in our school. We'll talk about the storage and things about the storage, our hypervisors, how IsardVDI tries to optimize the desktops, where they run, and how it decides where it's better to run. Networking, client users, so the users of the system connects to IsardVDI, and how this system scaled from the beginning. So an example of how the system can grow in your organization. So it's an open source virtual desktops. We are focused on desktops, providing desktops, not servers. Of course, we can run servers with the software. But we needed a fast and easy interface that allow all users, especially the teachers, to create, to be autonomous, creating their desktops, installing the software, and then delivering all the software, these created templates, we call it templates, to the students. We need an easy interface that was quick, and also that could be used by all the users in our organization. We have an interface for the users where they add new desktops, and they can start it, access to the client viewer. And we have also a quote system. We can limit the number of desktops they can start, they can create. Also, we have another part, this is the administration part, where we can access all the desktops, the users, hypervisors, and monitor all the system. Why we created IsardVDI? Well, the philosophy was a little bit what I explained. We need a system that brings autonomy to our teachers and also to our students. So we didn't want, as the IT staff in our school, we didn't want to spend more time delivering the software to the classrooms. And we tried both other virtualization systems and didn't adapt, especially the interface, to what we needed. So we will start with an example that maybe will explain what's the typical use case. The teacher usually comes with a software, the new software they have for non-robot they have just bought, and they need to install it, test it, and then deploy it to switch to computers to rooms. So now the philosophy has changed. We say, okay, just go to Isard web, install it. So we provide a form where on Isard where they can choose from templates already created. We create and optimize some templates. We call it the base templates, where they can start a new desktop. They choose whatever base template they want, or maybe templates that other teachers have created. And they can choose also the hardware, VLAN. They can attach the desktop to the VLAN where they are going to use it, for example. And after he has created the desktop and installed all the software they want, they want to deploy that to the students. So what we told them is, okay, just convert your desktop to a template and make it public to all the users. So when he goes to class, he says to their students, okay, create, look for my template and create your desktop. And usually the students have the desktops. This is a really fast sequence. How it works at the level of the disks we use. We create the base systems and optimize it. The teacher creates the desktop, installs the software they want to use in the class, and converts this to a template. So bases and templates are kept read-only, and after that the users just create a desktop, and all the data they write on the disk go to the disks they attach to the desktop. So this system is growing itself as users are creating templates and new desktops. This is a view from IsardVDI where we can see the hierarchy tree of the disks, how they are growing. What we use is a chain of disks. With QEMU image, you can derivate a disk from one disk, and you can continue so on. So with this system, we have, for example, more than 2,000 virtual desktops in only 8 terabytes of hard disk. So one of the things that with IsardVDI we have is a little bit only of space wasted using these chains. Also, IsardVDI has the ability to, you can configure it, you can set up IsardVDI to set the disks, the user's disks, on different storage servers. So the I/O performance that it's critical in these systems gets improved. It will balance the disks based on weights you can set. So with this system, we have lowered these budgets. We have balanced paths so, that we can set in different servers. So we have better I/O performance, and the disk are files, are TQO files, so you can just store it wherever you want and share it on the network with whatever system you want. We use NFS4 as the sharing system between hypervisors and storage, but you can use whatever you want. And the other thing that we use to lower budget is this cache. This cache we have tried to in Science.io and DM WriteBost. The first one is currently unmaintained, and we have changed to DM WriteBost. We have rotational disks that are slow, and we have NVMe disks really fast, but they are quite expensive. So we buy the cheapest ones in size, the smallest ones, and we configure the DM WriteBost to write all the desktops right to these quick disks, and you can see it here. Here there is the impact of writes of multiple desktops, and after that, in blue, you can see how the cache is layering the disk down to rotational disk. So we can lower the budget also using this system. Okay, how IsardVDI controls the hypervisors. We use generic KVM hypervisor. You can find it in main distributions. So there is no specific software needed to be installed apart from the main KVM packages. And we do all the monitoring from Isard software through SSH on all the hypervisors. So it's quite simple to set up. One thing is that we have tried with Intel server boards and these expensive boards, but in the end we have seen that if you balance the costs performance of these boards, using more commercial boards as hypervisors, you get a better performance system than using only small ones. Using high-end mainboards with a lot of features that are really costly. So sometimes it's better that you have a farm of hypervisors better than trying to buy a computer server, an hypervisor with a lot of RAM, a lot of CPUs. The cost will be too much for the performance you will get. So we assemble all the hardware ourselves. It's gaming, so you have lights everywhere, and LEDs. On the engine part of Isard, we have an orchestrator that will monitor all the time the hypervisors and the desktops that are going to be run on those hypervisors. So this algorithm has weights and will decide based on the free resources on the hypervisors and based on the resources needed for the next desktops that are going to be run, which is the best hypervisor where to place this desktop. Well, on the network part, we started with bonding with Ethernet cards of 4 ports, for example, and we set up bonding to have 4 gigabits. And after that, we start looking at 10 gigabytes, 10 gigabits switch. One thing that we have seen in the past 5 years is that you can get quite low price switches on eBay, secondhand, and they are rock solid. So it's a hardware part that you can buy it secondhand and you can lower a lot the costs. Maybe 3 or 4 times the cost of the new switch. So we use copper Ethernet switches and network cards and 10 gigabyte switches. Now we have bought 40 gigabit switch, also second-hand. And we set up all the networking with this second-hand hardware. Well, another thing that we have seen with our experience is that you have to split those 3 network streams and try not to mix that on interfaces, because it will get a bad user experience if you mix it. You have to send video, the client video, through one interface and one network. The access to internet of these desktops, you have to split it. You have to use another interface to send it. And of course, the storage part, you have to, you need a SAN network apart from the others. What it happened in the beginning is that we had video network, access to internet of the desktops mixed, and users experience a lot of lag when traffic on internet of these desktops were on the same interface. So this is the new 40 gigabit switch we have bought, and another 10 gigabyte switch that we have, and we split storage, access to internet, and video on those three networks. What we provide in IsardVDI is multiple kinds of access. We try to bring BIOT access, so the user, the students are starting to bring their laptops to school, and they can use the already created templates of the teachers on their laptops, so the network access on the school. Between all these viewers, with HTML5, we use an iOS Spice web client that we have adapted that works quite well for a normal use and brings access to a lot of clients that have only a browser. With the Spice, you need a client to be installed on the client computer, but you will have quite good performance and also some features like transparent USB plug on your desktop, on your virtual desktop. VNC works quite well also, and most of the operating systems already have a VNC ready. And RDP to access other kind of Windows clients. With the client viewers, we have set up some computers with Raspberry as the client, that they access our system and get the desktop. And well, it works quite well for a normal use if you try to do graphics, intense graphics, something like that. Of course, it doesn't work quite well. How it escalates all the system, how it can get bigger. Here we started with a system in one computer that we try with a few students, and we try if the concept could work. So you can have an IsardVDI for personal use, all in one computer. You set up IsardVDI, or even you can have a mobile computer. We have a cube. It's a mini ITX mainboard with a Xeon CPU and I think 64 gigabytes of RAM with an access point and direct 10G access network. So we can use this as a portable ISAT that we can set quickly on a new classroom. We have to install also on some laptops, just to show some demos of the software. Of course, you can have a setup of one computer only. The problem is that you only have one computer. If it breaks, you have nothing else. But we started like that. We had one computer for one class, and we used gigabit bonding of the network connected to the classroom switch, and they use it on that classroom. We have some pictures of we assemble all the computers we have in the school. But of course, this has grown a lot, and when you have a big infrastructure, where you want to deliver the virtual desktops, you need to set up a cluster for reliability, hypervisors, a pool of hypervisors, and you need 10G copper Ethernet or fiber Ethernet to bring all this traffic to your classrooms. Our solution, as we don't waste a lot of disk space with our desktops, was to set up the RVD between two NAS servers that have the hard disks. These two servers keep data synchronized with the RVD, and with Isard we can, as we said before, we share the disks on both servers, so the hypervisors will get this from both NAS servers, and we get a better I/O performance when all the desktops are writing on the disk. And we set up also a pacemaker cluster that brings us the possibility to fail one of the NASes, and all the system will work with the other. All the services will go from one NAS to the other if something goes wrong. And we use of course, second-hand network hardware to connect all these devices. More or less, what we have now is something like that, where we have those two NAS servers, and we have the hypervisors that will run the virtual desktops. And on clients, we have different kind of access, laptops, Raspberries. We have different kind of clients and connections. Also, to make it easy to install, we did a Docker setup. So we have a Git repository where there is the software. You can bring up an IsardVDI on your computer in minutes and try the software and its possibilities. What I have time, I think. What I will show you now, it's more or less how it works on a day-by-day basis. We have the quotes. Each user has limits on what he can create and run. So, for example, a teacher creates a desktop, sets a name. This is a real-time video, I think. And sets the hardware he wants to be set up on that server. One thing that happens is that a lot of software of armed robots and domotics and everything like that, the company gives Windows software. We have Linux on the computers, but they need to program that armed robot. So this is a solution with Spice. They can just do a transparent USB plug on the desktop. So the physical USB will be seen inside the virtual desktop. So the teacher just downloads the software, installs it on this newly created desktop. This is real time, so it started so quick. The NVMe cache works really well. The VM write burst cache that we have talked about before. So he will install the software, and after that he converts it to, well, we open software just to see that the desktop works quite quick. It's really fast. Also, the I/O on disk is really fast. And after that, this is the typical usage of the teacher. He installs the software that he wants to use with the students, and he tries that it works. And after that, he will convert it to a template. All this desktop based on a Windows that we have set up, he will convert it to a template, and it can be derivated on other desktops. So it can be used by other teachers or other students. Well, we shut down this desktop, and we just convert it to a template that will be seen by all the other users in the school. So it's a really quick system that we needed for school, and we tried all the softwares, and we couldn't find a system that was so quick in all this process, and that brings the autonomy to the teacher and to the students to create their own desktops with the software they want. Yeah. Now, the student in the class goes into Isard, and he will find the template. So he creates a desktop. This is a real-time video. We haven't cut the video. the students have less work on running desktops and hardware and all that. And we can access the desktop through different client viewers. So, if you have, thanks for your attention, and if you have any questions about. Yes? Our wives could tell that better than us. Yeah, he asks how long did it take for us to develop the software and also the settings of the hardware that is behind that. A lot of hours, of course. We like it. It was like a personal project that we wanted to try. Let's give a try. It works with one computer. Let's start more desktops. What happens? You have a lot of I/O. You have a problem. Okay, let's look. We need better hard disks with faster speed in writing. We have enough budget. Then we look. We have cache disks, so we set up cache disks, and we started growing that from maybe 4 or 5 years. We have been setting up all the system. What we have seen is that teachers that discover this software in the school, because we didn't promote this software in the school, when they discovered it, it was like talking between them, and it grew up. We couldn't stop that. It was high demand of these desktops. Yeah, you have an LDIP. Sorry, if I understand, you are asking how do we map the users to the system? Yeah. We have an LDAP system. We have 3 levels of. We have roles, we have groups, we have categories in our LDAP on the school that was already set up. We just have a plug, like a kind of plugin, a script that you can set up for your LDAP to automatically get the users from your system. Also, you can create your users, local users, without any authentication system. Any other questions? Yeah?
What about licenses in the proprietary software you
Yeah, that is a big problem. What is the question was, what about the licensing of the software you are running inside these virtual desktops? It happens the same with all the systems virtualization systems you try. There are policy, Microsoft has his own, and I think you are talking about Microsoft licensing. You need a physical license and then you can run that license on a virtual desktop, something like that. There is like a program of licensing virtual desktops, but this is the same in all the systems. There's no other way to do it. You need the physical license of that virtual desktop. Any other questions? Yeah? we are using, which version of DRDE we are using in our system. We are using, I think it's version 8, and now there is version 9. Version 8, you only have two servers, and we want to, when we have more time, we want to try new version 9 that it lets you set up more servers tied together, but we haven't tried yet. Sorry?
We tried cluster also, no?
Yeah, we tried Gluster in the beginning of Gluster as a system that will let us grow, but the performance, I don't know now, but it was 4 or 5 years ago, the performance of the system was so low that we started looking for cache disks and a system that didn't grow up in size of disks a lot. So we started developing our own system. Thefts.
But you need 5 servers.
Yeah, you need 5 servers maybe to set up a minimal. In the beginning, we tried Gluster, and we saw, that the performance was not so well. And with thefts, we saw that we need a lot of servers to set up the storage, minimal storage. So for us, was cheaper this setup. So in all the system, we try to keep the budget low. I don't know if you can, maybe you cannot see it so well. We monitor all the system, and as you can see here, these 2 peaks are the load of the NAS. When on top there, you can see the hypervisor on the desktops started. So it goes from 5, 6 desktops to 60 desktops. I don't know the time, I don't remember, but in a few times you have a lot of desktops started. And what you get is a high load on the NAS, the storage, on the storage. But the cache system in this small setup works so well. You can optimize it a lot. We have run with 6 hypervisors. He asked if we have tried the system to the limits. Yeah, of course, we like to do that during night and all that. And with 6 hypervisors, 64 gigabyte RAM, 128, 12 cores, 24 cores mixed all together, and gaming boards, most of them. We start 120, something like that, easily.
And when the problem in the classroom is that all the students make the start at the same time. The teacher says, "Okay, start," and the cache, it's very.
Yeah, the problem is
heavy,
the
I/O performance when 30 or.
Also, when the teacher has created a template, what happens is that he's in a class of 25 students, and we say, okay, let's go to IsardVDI and create a template now. And you create 25 hard disks, but with this system, the hard disk, it's 200 kilobytes, I think, and it will grow up as the student starts writing on the disk. So this process is not so consuming.
Yes, in the engine we we have a queues. No?
Queues. Yeah,
Queues.
we have queues of operations, so we can control how this behavior goes. If it's so quick, we can stop some stats and delay it a bit. Well, no one knows. We don't know, but it has been a software that the teachers are demanding more and more. So now we are trying to keep a stability of all the system, and as it is growing, because you need more resources and everything will grow. But well, I don't know till where it will reach. Yeah. 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 The commercial solutions, as he said, VMware and all these commercial solutions are really expensive. We asked also for 20 desktops, and it was like incredible. And the problem for us also was that they say, okay, you have also to go to this company and buy, or you have to set up this storage like this and this, and the costs were a lot higher. So it's not only the software, it's the hardware. They want to run their software. So we did it ourselves from ground up, all the hardware. We assembled the computers, we set up the switches and the network cards. Also we tuned the network cards, the performance of the network cards, and we did the software as also the interfaces we have seen didn't have this speed in creating and converting desktops to templates. Any other questions? Okay, thanks for your attention.